The speed time graph for a car is shown in figure. How far does the car travel in the first 4 seconds? Shade the area on the graph that represents the distance traveled by the car during this period. Which part of the graph represents the uniform motion of the car? Now, very first thing is we need to find the distance traveled by the car in the first 4 seconds. So where do we find it? First of all, this is the first 4 second. So the distance traveled by the car, let me write it as a statement so that it's very clear, which is represented by S, is nothing but area under the graph in a velocity or a speed time graph. And by the way, speed is measured in meter per second and time over here is represented by second. Always read this first before doing anything. I just wrote a statement, but if not, that's the first thing I would like to do. Now, what is the area under the graph? Well, let me show it to you guys by naming it. Say this is O, that's A, this point, that's B, and that's C. So that would be your area under the graph. So this would be equal to area OABCO. Right, so that would be your area under the graph. Basically this. So how will we find this area? That's the question. How to find this area? Well, we can find it in two ways. One, we can talk about the triangle OAB first. Area of triangle OAB, that would be fast. Then we add area of OBCO. If we do that, we'll be able to find the area of this entire section. Okay, so this is the game plan. First is we'll find the area of triangle OAB, which is a simple half into base into height. So the base here is 4 unit and the height is 6 unit. And all of this is approximately 12 meters. Because there's a bit over here which is a bit more than 12 actually. So this is approximately 12 meters. Now, the next part is the tricky part and you're going to get confused over here. So OBCO is your area that needs to be found. So let's see if you guys get confused or not. Hope you don't, but high chances that you'll get confused. Okay, so don't think too much, just listen, let it sink in. So how do you find this area? We have to go to our old method of counting the squares. So that will be number of squares. Well, if it was only this, then it would have been easy, but it's not so. That's why I told you it's going to get confusing. And multiply the distance that a square represents. That's confusing, right? What does that mean? See, each of this square is of a particular unit. Let me show it. Distance that a square represents. So to understand this, let me draw a square. And over here along the x-axis, it is going to have, it's going to be of 2/5 seconds. It's representing 2/5 of a second, right? Because there are 5 parts between 0 and 2, so that is representing 2/5 of a second. And along the y-axis, there is 1, 2, 3, 2/3 of meter per second. This is what it's representing. So basically, this would be equal to 2/5 of a second into 2/3 of a meter per second. And as a whole, this would be equal to 4/15 meters. So each square is representing 4/15 of a meter. It is not representing 1 meter. Please understand this. It's representing 4/15 of a meter. Right? It is all because of the scale factor. If the scales were different, and you would have been representing something else. If you're able to understand this, then you didn't get confused. If not, it's okay, let it sink in, just take some time. Think about the units, right? It's physics. So I told you guys, graph can be complicated. It's not that easy as what you guys have seen till now. So let's look at the number of squares in OBCO. So to do that, we need to find or count, not find, basically count. So how do we count? Like this. There are 1, 2, 3, 4, 5. 5 full squares. Plus 1, 2, 3, 4, 5, 6. 6 3/4 of a square. Plus 1, 2, 3, 4, 5, 6. 6 half of a square. Plus 1, 2, 3, 4, 5, 6, 7. And all of them put together 8ish 1/4 of a square. Again, it will make my calculation easy, right? So all those values, 4 plus 3/4 would be 18, 4 for the 16, and 2 remaining 4.5, plus this is 3, and that's going to be 2, and this is 5, 5, 10, 14.5 squares, not meters, this is squares. So there are 14.5 approximately squares. Therefore, area or distance represented by OBCO is equal to 14.5 into 4 by 15. 14 and 14 gets cancelled. 4 meters. So that's it. You got it? So all of this put together represents 4 meters approximately. It's not exact because, oh yeah, by the way, I cancelled this and this. So this is approximate. I mentally cancelled it. I didn't tell you guys. So 14.5 divided by 15 approximately is 1, because we can't go to the detail of calculating all of that. It will be too hectic. Now let's look at the total distance, which is sum of 4 meters plus 12 meters, which represents 16 meters approximately. So this is your answer. Okay. So this is your first answer. There's second one also, my bad. The second one is, which part of the graph represents uniform motion of the car? So uniform motion in speed time graph is represented by a line which is parallel to x-axis. So this is something that I speaking of from, well, almost 3/4 of the topic. So I hope you guys get why this represents uniform motion, because there is no change in speed. So that's the very definition of uniform motion. So from, you can see over here, 6 seconds approximately. 6th second, the car is traveling at a uniform motion, right? Again, uniform motion is wherein you are traveling equal distance in equal interval of time, that is a constant speed. That is what a uniform motion means. If you want to remember this, make a note. Uniform motion means constant speed. This would equal to 0 acceleration, right? 0 acceleration. Got it? Okay, so this is your answer.